Next, we're going to look at relationships between lines, coincident, parallel, or perpendicular lines. Coincident, I've always said coincident, and Mr. Kowalty laughed at me very hard last year while he was teaching this lesson and told me it's coincident. Oh, well. So coincident lines are lines that have the same slope and y-intercept. This is not an IB term. This is a term that your textbook uses, but I've never seen this on an IB exam. But it is a common word for lines with the same slope and y-intercept coincident. Parallel lines, hopefully you are familiar. Parallel lines have the same slope and different y-intercepts. And different y-intercept. Again, this is really sloppy. My notes that are uploaded are much prettier. And finally, perpendicular lines. Have slopes that are opposite reciprocals. So slopes are opposite reciprocals. Opposite reciprocals. You could also say that the product of the slopes reciprocals. You could also say that the product of the slopes is -1. Lines don't have to be one of these three. They can be the lines on top of each other, coincident. They can be parallel, or they can be perpendicular. Sometimes lines are just intersecting. If they don't meet any of those three criteria in 2D, then they could just be intersecting lines that aren't perpendicular and not coincident. By inspection, we can determine if each pair of lines below are parallel, coincident, or intersecting. First one, hopefully you notice the slopes are different, but the product is not -1. So they are just plain intersecting lines. Again, if you want to do this one on your own first and then check the answers, I strongly encourage that. B, if you isolate for y on the second equation, you get 2x minus 3, and you can see that that is the same equation, same slope, same y-intercept. So B, those two are coincident. C, if you isolate for y on the second equation, you get y equals, I believe, 2x plus 3. And so you can see the slopes are the same, but y-intercepts are different, which means that the two lines are parallel. I'm just going to write the answers to the next three. You can isolate for y on your own and verify that that this is true, that these answers are true. D is parallel. E, the lines are intersecting, not just intersecting, but I think if you intersecting, this problem's weird. It said parallel, coincident, or intersecting. But if you do actually isolate for y, the first one has a slope of obviously 2. The second one has a slope of -1/2. And so the slopes are opposite reciprocals, which means they are not just intersecting, but they are also perpendicular lines. And finally, F, if you isolate for y on both of those, you'll see they have the same slope and different y-intercepts, so they are parallel.